hopefully by now you've taken a look at the sales performance data, tried to build some models using our model selection techniques. If you haven't done that, I'd encourage you to pause the video and try it by yourself. Let me show you how I would go about using the automated model selection techniques to try and build a good model with the sales performance data. So first we need to read it into Enterprise Guide, Analyze Regression, HP Linear Regression. Sales is our dependent variable, the other 7 are explanatory variables. We want to try using all 7 of them, add those in. And then go to selection, and first off try forward selection. Change to adjusted R² for these, and hit run and see what we get. Now you might notice over the side I've got an Excel spreadsheet open. I'm going to be using this to keep track of my results. Usually I would do this with pencil and paper, but I'm doing it in Excel here so that you guys can see what I'd be doing. So as I'm looking down here at the results from forward selection, I see that according to adjusted R², the best model was one with accounts, advertising, market potential, market share, change, and time included, but not workload. So I would go over here and put check marks or a Y for yes here beside those first 6, but not workload, to remind myself that forward selection using the adjusted R² stopping rule chose those 6 variables, not this one. And then since we've got it, we can also look at what we got using the Stepwise criterion. We actually got a different result. We got accounts, advertising, market potential, and market share should be included. So that's accounts, advertising, market potential, market share, but not change time or workload. So already we've got 2 different candidate models, 2 potential models that we could investigate further. Okay, now let's see what backward elimination gives us. So we'll modify our task, in selection choose backward elimination and hit run. Let's see what we get this time. Using the adjusted R² criterion, backward selection chose the same model that forward selection did. Eliminating workload, we've got the asterisks beside this adjusted R² to say that without workload but with all the other variables was the best according to adjusted R². According to the Stepwise criterion, we actually got a different result though. So we started with all of our variables in the model, removed workload and accounts, and that gave us the best model according to backwards elimination. So now we've got another candidate model with these 5 variables: time, market potential, advertising, market share, and change, but not accounts or workload. Okay, finally let's do stepwise regression, or stepwise selection as Enterprise Guide calls it. Hit run and see what we get this time. Remember, stepwise selection starts like forward selection in the sense that it starts with an empty model and then adds more variables. And in this case, accounts, advertising, market potential, market share is the best according to both. So was that accounts, advertising, market potential, market share, the same model that was chosen by forward selection using the Stepwise criterion. So we've actually got 3 candidate models here. We've got this one with market potential, advertising, market share, and accounts. We've got this one with all 6 except for workload. We've got this one, all the variables except accounts and workload. So what I would do next is estimate again each of these 3 models and pay more attention now to all of the other output down here. start looking at root mean squared error. Which of our models has the best root mean squared error? Start looking at our individual variables. Do we have any insignificant variables in our model? As we do this, that'll start to give us a better idea of what is a good model, perhaps even the best model for us to choose.